Hi, good afternoon and welcome to this lunchtime chat. I'll go with chat. It's going to be an informal discussion here in Barcelona at the World Seed Congress. My name's Will Holmes. I'm the Global Product Manager responsible for seed applied nematicides at Syngenta, and I'm joined today by Emeritus Professor Richard Sikora, who has a really rich experience in soil ecology, biology, agronomy, plant pathology, and is the former head of soil ecosystem pathology at the University of Bonn. So, welcome, Richard.
Oh, it's good to be here. It's good to be here.
Thank you. So, if I can just move on the first slide. Okay, well, the topic of our conversation today is the unseen enemy, the state of the art and visions for the future of nematode management. So, Richard, you've just published a book recently, or you've been involved in the publishing of a book recently on this very topic. It's now appeared on the slide. So this new book tries to document everything in this area. Could you just tell us a little bit around why the unseen enemy is a key topic that we should all be thinking about?
Yeah. Well, I think probably 99% of the people here in the audience have never seen a nematode. 90% of all farmers have never seen a nematode, and they don't even know they exist. And that's one of the problems with this complex. If you don't know they're there and you don't know what they're doing, how do you control it? Why do you control it? Why do you spend money on trying to control it? And that's the reason for the book. It's to basically show people, farmers, producers, seed companies, what is needed in this particular area of the unseen enemy.
Okay. So what are the sort of impacts we might see on crops in terms of yield or quality? What are we talking about here?
Yeah. Well, this unseen enemy is actually an unseen army. Every plant, as soon as the seed germinates, and the young root starts to grow, that root is attacked by 1, 2, 3, 4, or 5,000 nematodes with stylets that look like you're getting injected with COVID antibodies. And those nematodes, they deform the root system. The root system the architecture of the root system is deformed. This affects plant growth drastically, especially in their drought conditions, water stress, fertilizer stress, et cetera, et cetera. So they're extremely important, and they're also extremely important in that early root growth phase. I call it the pathozone. That's where we have to protect the plant so that we have high yields at the end.
Sorry, the pathozone. Just explain that one for me.
The pathozone is a cone of soil around the germinating seed. We're talking about maybe 1 kilo of soil. And in that 1 kilo of soil, you have anywhere between 10 and 30,000 plant parasitic nematodes at the time of planting. They're sitting there, they're just waiting. And when that plant germinates, they're attracted to the root system by the exudates of the root. And then they damage it. They hit the root tip. The root's shallow. It doesn't take up moisture as well. The root is not as functional.
Okay, so you've got a breadth of experience globally. You've been involved in research around the world. Where have you seen or experienced particularly severe examples of nematode damage?
It's sort of interesting that some of the most severe damage is in the Western world, where we have modern agriculture, because we're in basically almost a semi-monoculture system. Soybean, 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 maybe maize, soybean, 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 or maize, 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 and then maybe a soybean crop. You have monocultures in, for example, Florida, California, of carrots and tomatoes, all vegetables that are highly susceptible. Okay. And there you see a lot of damage, but of course, the modern farmers in these areas can use modern technology to limit the damage in that pathozone. The pathozone is the most important part of the whole thing.
Okay, so that's an example in a country with lots of modern technology. I know you're involved in working Africa at the moment. What are the wider social implications of the lack of options for control of nematodes?
Mm-hmm. Well, these unseen enemies, these plant parasitic nematodes that damage that root system, they do it all the time. There is not a plant in the field that is not damaged all the time. They're always there, and they're there in multiple numbers. But the The problem with Africa, India, other countries in the world, the farmers are small. The farms are less than 1 hectare. And if you have a farm with less than 1 hectare, you do not have the funding or the technology or the knowledge to do an integrated system.
Yeah.
And if you look at Africa right now, and I'm working on complexity of food systems there in South Africa, these farmers are now living at the lowest level of nutrition that you can have. They are basically not starving, but they have just sufficient food to survive. And the population is going to double in 30 years. All of Africa, 30 years. And if you double that and you don't increase food production and those small farms, those people are in real problems. It's a very big problem.
Okay, so the title of this session was the current state of the art and the vision for the future. So what is the current state of the art of nematode control?
Well, I didn't show the slide here, but we have probably 30 or 40 different technologies that we can use in the Western world to control nematodes. We have monitoring systems, we have information systems, we have seed treatment systems, we have resistant varieties, we have modern rotation systems. These are all there. In many parts of the world, they don't have access to those technologies. And this is a problem because if you don't have access to it, you can't control your problem. You can't control that unseen enemy. So that's one of the problems we have. And the future is not based on these old technologies, it's based on new technologies that are being developed right now. Things like remote sensing with drones. We can actually, with a drone, measure the population density in the soil under a crop. I can actually tell you how many nematodes are in the soil during the season with a drone or with a satellite. And then we have a method of measuring the electric conductivity of the soil. Like there's a slide, you're going to have to go further down. That's the damage. Those are the poor people that don't have the technology to work with. Those are the drones. And then we have what we call electric conductivity. We can measure the texture of the soil in a field. So you pay a custom consultant. He makes a map of your field, the texture of the whole field, and he can tell you where the sandier soils are, and that's where nematodes are most important. Once that map is made, that tractor can go through the field. It can put a seed treatment here. It can put a resistant variety there. It can do a large number of things. And this map is good forever because the soil texture doesn't change throughout the field. So this is a really interesting technology. We also have CRISPR now in the pipeline, which is extremely important for new breeding systems now. And something that's interesting is we have beneficial organisms that are now being put on the seed. We have entomopathogenic nematodes that kill insects in the soil. We have bacteria and fungal endophytes that go into the root system, induced resistance. I mean, we have some fantastic technologies in the pipeline, and it's just a matter of time before they get on the market.
So how, you mentioned several new technologies there. How widely adopted are these currently?
Remote sensing is reasonably widely accepted for looking at yield, looking at fertility, but it's not accepted for nematode damage because we don't have the programs right now to transfer the reflectance of the crop into the population density in the field. We can tell you where the nematodes are, where the hot spots are. If you know where the hot spots are, you can treat those hot spots with a seed treatment, with a fumigant, whatever you have in mind. But we don't have it for most nematode problems.
Okay.
Not yet.
Not yet.
But the technology is there, the mathematics is there, the modeling is there. I mean, it's only a matter of time until this occurs. No, it's just, we got to start moving. We got to start moving.
Definitely. I spend a lot of my time in my day job, not hosting these sort of conversations, thinking about that direction and where we're going to go.
You know, you're getting me all excited right now. You know, talking about my hobby here.
Well. Absolutely, that's why we've got you here, for that excitement and that vision of the future. So today's audience and this event is focused on seed and therefore seed treatments. How do you see seed treatments playing a role in that mix of technologies you've just described?
I started working with seed treatment in 1973. You know how old I am now. In 1973, I was putting bacillus on the seed already, on peanut seed, on cotton seed, to control nematodes. It never went because industry had nematicides. As the nematicides started to lose foothold because they were too toxic and new nematicides weren't coming on the market, the biologicals should have taken over, but they're not as efficient as a chemical seed treatment.
Okay.
And right now we have 2 or 3 new chemicals. Timerium is a new one I think you're producing. That nematicide is extremely important because, or any nematicide that you can put on the seed and you protect that pathozone. You have to keep the nematode out of the root for 2 weeks, no longer, 2-3 weeks. After that, you don't even have to kill them, you just have to inactivate them. And then, once the root gets established, the plant can grow, it can tolerate. Basically, the plant becomes tolerant to attack. And this is extremely interesting. But what people don't understand is you don't have to kill the nematodes forever. You just keep them out of that pathozone for 3-4 weeks. It works on sugar beet, it works on tomatoes, it works on almost all crops. And that's where seed treatment is, for me, one of the most important technologies we have. It's just important.
Okay, so that's about the start. That's about establishment. That's about the very early stages of crop growth. So you mentioned Timerium technology, which we're in the process of launching. Here today, we're the first announcement of the new product Victrato, which is going to be a seed-applied version of Timerium. Timerium has activity on both nematodes and soil-borne diseases, particularly Fusarium. I know you've done some work in this area.
Show that slide.
How do you see the interaction of that one of the two, of nematode with disease?
We call nematodes an unseen enemy because you can't see them. But they're there. They're always there. Every plant is being attacked. And these nematodes have a stylet. Like I said, it looks like one of those injection needles. And they suck out the shaft of soil. They wound and the root surface. And by wounding the root surface, they open up lesions, more exudates come out, and this attracts fungi, root rotting fungi. These are not serious pests, but there's weak to moderately strong pathogens, and they rot the root like you see in that slide up there. They're extremely important, for example, in banana, in cotton, in peanut. They're important in soybean. And this complex of fungus and nematode and this interaction is extremely important for yield. And that goes on after the pathozone is protected because the nematodes keep on coming in. They just don't disappear. So the nematode fungal interaction is, for me, one of the most important aspects of future biocontrol, integrated control. And that's where these new products like Timerium are important because you have a product now, as far as I know, that also controls Fusarium. And Fusarium is the most common root pathogen, weak root rotting pathogen on all crops. If you take a piece of root and you isolate all the organisms in that root, you'll always find Fusarium in that root. Some of them are good, some of them are bad, but the bad ones are bad, and they cause that root rot. Nematodes don't cause root rot. Nematodes don't cause any lesions. They damage the cells, but the damage you see here, the colors, that's caused by fungi and bacteria. And this is important to control. And this is especially important now that we have a problem with food security in the future. We have to increase yield. We can't afford not to increase yield worldwide on every crop. We have, according to the FAO, we have to increase yield 1% every year on every crop. That means in 20 years we have to increase yield 20%. Yeah.
Yeah.
We've got work to do.
So
a lot of work to do.
We've got a lot of work to do.
Yeah.
So you've studied.
I'm retired. I don't have to work so hard now.
So you've studied. I think you said since 1973 you started working on nematodes.
I started. I don't want to tell you when I started. I started working on nematodes in 1967.
Okay, so for those of us who are currently working in nematodes, if you're claiming to be retired, I'm not sure that's true. What would you encourage us to do? What direction would you like to see us investigate?
I mean, for modern agriculture, I would like to see a lot more done with remote sensing.
Yeah.
I'd like to see remote sensing used to determine population densities and hotspots in the field, so you treat specific areas and not the entire field. Very important.
Okay.
I would like to see a lot more work on seed treatments. I would like to see more chemicals coming on the market that are even more powerful than now, maybe. And one thing about Thymeurium, which fascinates me, is this is a new technology. The nematicide actually kills the nematode. All the other nematicides of the past, Temic, Vidate, Nemicor, they don't kill nematodes. They only inactivate them. And this one kills. So in that pathozone, you actually kill that population. And that makes that product extremely important. If you put Temic on there, it inactivates them. And after 3 weeks, 4 weeks, they reactivate and they keep on eating, feeding. And most people don't know this. And that's why in banana, for example, you treat the banana with Temic in the past and Nemicor, you had to treat it 1, 2, 3 times a season, because every time the nematodes start to get reactivated, the damage increased. So this is why Thymeurium and other chemicals of that nature are important, because it kills. You're reducing that unseen enemy. It's not unseen to me, but to you people it is. You're decreasing that population. You're decreasing that early root penetration damage. That's just really important.
Yeah, I've heard you talk about nematode management rather than necessarily nematode control as such, because it strikes me that this is a population in the soil which is ever present,
yeah.
And something we need to learn how to produce effectively good quality crops of sufficient yield alongside that population. It's not a complete control. Is that a fair description?
Up until this product, you did not control the nematode. You inactivated it. You manage nematodes. We always were trying to manage them, basically. With this product, you're actually killing some nematodes. You're actually controlling it, which is interesting, no? But the integrated nematode management is going to get highly technical. And we're developing what we call decision support tools. I think industry is doing the same thing. These decision support tools are important for farmers. They're important for farmers around the world, except in the developing countries.
This is a contract. You've talked a lot about new technologies coming through for nematode management, but also talked a lot about the problem in the less developed markets where technology maybe isn't as accessible or scale of farming doesn't support it. How do you see us squaring that particular circle?
Well, I'm hoping that the new technology with CRISPR will develop new resistant varieties. This would help the underdeveloped world immensely. If we can get varieties to these poor people that are resistant to nematodes and fungi, we can increase their yield. You have to imagine the yield of maize in Africa on a hectare basis is 1 ton or less. In South Africa, it's 9 tons. In Europe, the United States, it's 12 tons. They only have 1 ton per hectare. And that's just enough to feed their family. If we can get a resistant variety in there to nematodes and to fungi, we can increase that root system that makes the plant more resilient to, for example, water stress, heat stress. So there's a whole batch of things that can happen if we get that right. So CRISPR would be very important, new varieties with resistance for the poor countries.
Because that's a technology which, through the current value and supply chains, we can deliver to everybody. Is that?
I think you can.
That's your thinking.
You may have to give it the technology free to these poor people, but if you don't want them all migrating out of the country and fighting and dying, you've got to do something, no? And you may have to subsidize the seed, the new seed.
Okay.
No?
Yeah.
I may be getting out of control here.
This is one of the subjects for today was around the social impacts of the problem, which absolutely we see at the moment. Food security is a big topic. So why nematodes? Why have you been involved in nematodes for so long, or researching nematodes?
I received a position in Germany to be a scientist for international plant pest control across the tropics and subtropics. So I worked in 40 countries. I had 96 PhD students, 80 master's students, and they were international. And this just got me so excited to have these young people working all around the world and also coming in and giving me information about what's happening in their country. And that's how I got involved in the poorer countries. Germany's nematodes don't interest me. They have good nematologists and they take care of them. But in Africa, India, parts of China, South America, we have a large number of problems and no one is helping them, or very few people are helping. Extension doesn't exist, basically. It's another technology that will be very important in the future. Cell phone technology, internet technology. Every African farmer, no matter how poor he is, has a cell phone. Everyone. It's unbelievable. So But the social content is very important. You have to imagine we put 100 kgs of NPK on maize in the United States, up to 200. The small farmers of Africa or India, they get 1 kilo to 5 kilos. So how are they going to produce food if they can't afford more fertilizer? They can't afford a seed treatment right now. So this is a challenge. It's a monster challenge.
Yeah.
Monster challenge.
Yeah, you sound you're very passionate about the subject.
Yeah. Oh, yeah.
Both about the agriculture and the challenge posed by nematodes particularly. It was interesting, just this morning here, I was talking to someone who didn't quite realise there were nematicides available as seed-applied products. So I think, to your point, the awareness of the problem, the awareness of the pest in the soil, and the solutions that are available is one of our challenges.
Yeah. You should have mentioned that this book was also open access. We made it open access with the help of Syngenta. And that book is available to everybody in the world. And it's been downloaded 3,000 times already. That means people are looking at this book because it's free. And I think that's important. We have to do more in that direction. Yeah.
So is that one of the drivers behind the book? Is that one of your drivers behind pulling the book together? Was this need to educate, to raise the awareness?
When I came up with the idea, I talked to Syngenta, they were at a meeting, and they thought it was a great idea, but I said I will only do it if it's open access. And they paid for it. And it wasn't cheap, but it's important.
Okay.
And if you're interested in development, I have a book called Transforming Agriculture in Africa. Also extremely interesting, what we have to do for these small farmers in that rural-urban continuum. Extremely interesting. Just, you know.
Yeah. So if you were in my seat, if you were in my chair launching Victrato as we are at the moment, so we're taking it forward, what would you recommend? What would I do? What would you advise me to do, being responsible for a new nematicide seed treatment coming to the market?
Well, first of all, I would like to know if you ever saw a nematode under a microscope.
I've seen lots of pictures of nematodes under microscopes. I attended in my first nematode congress recently, and my big learning from that was that I now know people who know about nematodes. Yeah. Yeah. I'm not a nematologist, definitely not.
Well, I mean, I think it's important to have maybe a 2 or 3 prong attack approach. I mean, you want to make money, so you want to work with the Western world where they can afford these things. But I think every company should have an arm that looks at trying to help the poor of the world. Like you said, it's in my heart. We have to do something with the poor. And that's difficult. It's very difficult. I mean, if they can't afford 10 kilos of fertilizer, how are they going to afford a seed treatment? But that has to be done. Okay. I would do it in a 2-prong attack, and I would look at these new technologies of remote sensing. Okay. I think that's key.
It's key. So the technology itself of applying the product to the seed is part of the solution. But then you're now thinking about how we can identify, diagnose, and apply accurately those same technologies.
In sugar beet, we can map a field. We know exactly where the hot spots are. So we could treat it with a seed treatment on sugar beet. What we can also do is we can determine the population density in the field, in those hot spots, and we know what happens if you put a non-host crop in, 2 non-host crops in. We know what happens to that population because we can calculate that with a model. It's all in the book. It's all in the book.
Well, I was given a copy of the book when I started my new role, so I'm trying to learn about the nematodes.
Yeah, I know you are.
More time on the microscope clearly is one of the things I need to work towards. I'm sort of drawing us to a close here. I'm conscious of time a little bit, but if there's an area that you could still encourage someone to research, your next wave of PhDs coming through, which direction would you send them in?
I think they have to start thinking about management.
So
we're forgetting this. 20% of the people in that book are retired. We could not find highly qualified applied nematologists in the entire world to do some of those chapters. And this is depressing. So we have to start showing science that it's not all about gene technology. It's not all about identifying certain sensors and we have to start showing people that integrated management's important. across the board with all the technologies. That has to be done. Otherwise, we have nobody to do this. You go to Africa, many of the African nematologists are molecular biologists. They haven't even identified a nematode yet. And
so now you're talking my language of agronomy, which is integrating different technologies to solve problems.
Agronomy is a key. Agronomy is a key, because if we don't have good fertility, if we don't have good organic matter in the soil, you get non-reactive soil. So it's a dead soil, basically. Yeah. In some parts of Africa, if you put a fertilizer in a non-reactive soil, it doesn't react. The plant doesn't take anything up because there's no organic matter. It just washes out.
So actually then, in my language, you're thinking about nematode management or crop management way in advance of the actual the crop you're focused on.
Crop health management.
So this is cyclical. This is long-term stuff.
A lot of people talk about soil health, and I don't like that term because soils don't get sick. No soil gets sick. Plants get sick. So we're talking about two different things when we talk about soil health. We're talking about soil fertility, and we're talking about plant health. And there's two different things. Soil is basically a vector of plant diseases. Soils carry all these diseases. They carry the nematodes, so they're actually a vector.
Some of those processes, like the inherent fertility of a soil, is based on being alive, the carbon, nitrogen cycles, that relies on the biology of the soil to drive that fertility. Right. They're the sort of things you think about.
Well, that's part of the fertility side.
Yeah. So since moving into this role, my previous role was focused in European agriculture. This role, global view, one of the things I'm absolutely fascinated about is seeing agriculture in different parts of the world. So post-COVID, hopefully that's going to be possible to get out there and start understanding some of these systems in detail. Where would you recommend? Where would you encourage me to go and visit?
What crop would I recommend?
Well, crop or region. Where could I learn the most?
Something that always fascinated me during my active career was rice, paddy rice. Every paddy rice plant is attacked by a nematode. And it can be controlled if you can get an endophyte into the plant. Because once that plant is in the field and you flood it, that field becomes anaerobic. That means nothing can get in. And they can't get back out. So they're stuck. It's like being in jail. Now, if you can get a seed treatment or a bacteria, an endophyte to put on the seed, you can have a massive effect, I believe, a massive effect on yield. And I couldn't do it because rice doesn't grow very well in Germany. So I was never able to really get my fingers on it. But the endophytes are there. They're there.
Okay. Well, rice is very different from any crop I've been directly involved with. So it is on my radar and one I'll be working with.
What's that?
It is on my radar. It's on the plan.
I hope so. Wheat is extremely important in the Middle East, all the way up into China. And even wheat is heavily affected with nematodes and fungi, root fungi, just complex diseases, no? And we have nothing for some of that, no?
Well, that's one of the fascinating things about the product we're launching at the moment. Samarium, with its dual mode of action in both disease and nematodes, actually, it makes it a very complex project to be involved in, but fascinating in terms of the diversity, the different crops, the different targets that we're going after. And actually, by crop, it varies by country, depending on what the prime driver is. So wheat in Australia, a big issue is crown rot, a fusarium-based disease, whereas wheat in other countries, we're focused on nematodes. So actually, this is one of the challenges I'm getting to grips with now, and I've spent a year trying to understand, is exactly this complexity. Yeah, well, so far, I think we're pretty much covered on the crops and the diseases that you've talked about. So,
again, maize is another one. You shouldn't forget the maize. No.
Yeah, no, maize, absolutely. And actually, that's one of the crops that's both in developed and less developed systems that we need to be thinking
I think
about.
You told me yesterday somewhere with coffee that maize doesn't react as well to your company's other. Well, there's a reason for that. Maize has been bred to be extremely tolerant to everything. It's a strong plant. It's a highly vigorous plant, so the roots go fast. So nematodes don't normally damage it. They're highly fertilized. 100 kilos, 200 kilos per hectare of fertilizer. If you take that plant and you'd put it in a country where you only have 50 kilos of fertilizer, you have a less healthy plant, a less strong plant. Your tolerance of that plant to nematodes and fungi changes. And that's an area that you have to look at.
It's interesting you say that. Some of the most striking results I've seen from the trials we're doing are actually in maize. So even though it doesn't necessarily show the symptoms, you take some of the results we're seeing in Africa, southern Africa, where the fertilization isn't as high as in North America.
Kilos.
And the yield response that we see there from controlling the nematode
is higher.
Is huge.
Yeah.
Much higher than other
That's
parts of the
because because you're not taking care of the soil fertility
first.
It's not optimum. The root's not optimum, and the plant is more susceptible to the disease. It's basically it's logical now.
So actually, where you see a stress, be it water, nutrient deficiency, any other type of stress, the problem is just exacerbated, really.
Right, and I didn't mention. I think I mentioned it in a word, but root architecture is going to be extremely important in the future, especially as we have climate variability, not climate change. That's happening. We got this climate variability. And that's very difficult to predict.
Before I let you go on to a different discussion about climate change, I believe I'm being signalled tea from the back, which I suspect is time.
Hey.
So thank you very much, Professor Sikora. If anyone would like to speak to Richard, speak to us about Victrato, please come to our booth here at ISF. Richard will be on the booth between about 1:30 and 3:30, I believe.
And if you have any questions afterwards, you can send me an email. I answer my emails almost immediately sometimes, so I answer my emails.
Okay. Thank you very much, and thanks for joining us today.
Thank you.